Hi everyone, in today's lesson we're going to talk about comparing z-scores. The only way for me to make sense of this is to explain through an example. So I'd like to try example number 1. So a set of mathematics exam scores has a mean of 70 and a standard deviation of 8. As I read this, I'm going to take some notes. So math has a mean of 70 and a standard deviation of 8. And then it says English exam scores have a mean of 74 and a standard deviation of 16. So mean 74, standard deviation of 16. So the question is asking, for which exam would a score of 78 have a higher standing? Well, in order to compare two different data sets from two different means and two different standard deviations, we have to do something called normalizing the data. So let's write this down. To compare two sets of data with different means and standard deviations, we must normalize the data. So again, to compare two sets of data with different means and standard deviations, we must normalize the data. And what does that mean, to normalize the data? It just means to convert to z-scores. So it just means convert to z-scores and then compare. Okay, so again, to normalize just means convert everything to a z-score and then compare them. Okay, so let's look at this first part where it says math with a mean of 70 and a standard deviation of 8. I want to take this data value of 78, so I can even put here data value of 78, and we'll even put it here too because this is the data value we want to compare. And what we're going to do is we're going to use these three pieces of information in the math and these three pieces of information for the English, and we're going to convert this data value to a corresponding z-score. So just to refresh our memory, a z-score can be found by taking the data value. We're going to subtract the mean and divide by the standard deviation. Okay, so let's do the one for math. So to find the z-score, we're going to take the data value, which is 78, subtract the mean, which is 70, and divide by 8. If we do that, we get a z-score of 1. Now we'll do the same thing with English. So for English, we have a z-score equaling data value, which is 78, minus the mean in this case, which is 74, divided by the standard deviation, which is 16. If you put that into the calculator, you should get 0.25. So when you're comparing to see whose z-score is higher. So is 1 bigger or smaller than 0.25? You should be saying 1 is bigger. So the answer to this question is math. You would have a higher score in math because the z-score is higher. Okay, let's look at example number 2. Same type of question. Let's just read it first and take notes as we go. Mensa, the largest IQ society, accept IQ test scores as well as SAT scores as indicating intelligence. Assume that the mean combined SAT score is 500 with a standard deviation of 300. Michelle took the SAT and scored a combined 2,070. Eileen took a traditional IQ test and scored a 129. On that test, the mean is 100 and the standard deviation is 15. From these test scores, who is more intelligent? So there's two test scores, or two tests that are being taken here. An SAT by Michelle and an IQ test from Eileen. All right, so let's figure out what the mean is, the standard deviation, and the data value for Michelle. And the same thing, find the mean, find the standard deviation, and find the data value for Eileen. So why don't you pause the video and see if you can put that information in. Okay, the mean for the SAT is 1,500, standard deviation was 300, and the data value that we're talking about is Michelle's, and Michelle's data value is 2,070. Now for the IQ test score for Eileen, Eileen scored a 129, so that data value goes here, and on that test there was a mean of 100 and a standard deviation of 15. Now, in order to see who's more intelligent, we have to see who has a higher z-score. So more intelligent means higher z-score. So let's continue to change their information into z-scores. Z is equal, for the SAT now, we're going to focus on this one, the data value, so 2,070 minus the mean, which is 1,500, over the standard deviation, which is 300. So this, if you put that into your calculator, you should get 1.9. Now feel free to pause the video and check my math because I could be wrong. Now let's do Eileen's. So the IQ test score, we're going to change her data value of 129 to a z-score. So 129 minus 100, minus the mean, over 15. If you put that into the calculator, you should get 1.93. So they're very close, but Eileen wins. So the answer is, who is more intelligent? The answer is Eileen. Okay, let's look at example number 3. Two versions of a standardized test are given, an April version and a May version. The statistics for the April version show a mean score of 480 and a standard deviation of 24. The statistics for the May version show a mean of 510 and a standard deviation of 20. Assume the scores are normally distributed. Joanne took the April version and scored in the interval 510 to 540. What is the probability to the nearest 10,000th that a test paper selected at random from the April version scored in the same interval? So we're talking about the April version and we're talking about probability. So this is actually something that we discussed yesterday with the normal curve. So they're talking about the April version. Let's write down the statistics from April. So it says the April version shows a mean of 480. So let's write down mean is equal to 480. And it also says a standard deviation of 24. So what do they want to know? It says here that Joanne took this test in April and she got in this interval. We want to know the probability that this test paper will be in that range. So let's just draw a picture so we have an idea of what's going on. Here's my normal curve. In the middle is my x bar, or my mean, and in this case it's 480. And where would 510 lie? 510 would be a little bit higher, I don't know exactly where, and then 540 would be even higher. So I'm going to put 510 here and 540 here. So I want to know the area between these two data values. And in order to put this into the calculator, we discussed this yesterday, we need to convert to a z-score so that we can put into the calculator in the normal CDF, we need to put in a lower, a higher, or a upper, sorry, a lower value, an upper value, a mu of 0, and a standard deviation of 1. And that would give us our answer. But in order to do that, I can only put in z-scores. So we need to convert this number here, 510, to a z-score, like a 1, a 2, a 3, some sort of decimal, and 540 as well. So I'm just going to put that information, I guess, over here. So 510, the z-score for 510, so z is data value, 510, minus the mean, 480, over standard deviation of 24. So that is 1.25. Pause the video, check my math. For 540, I'll put the z-score up here, I'm running out of room. 540, the data value, minus the mean, which is 480, over 24. If you do that, you should get approximately 2.5. Again, check my math. So what I just did was I took these two values, 510 and 540, and turned them into z-scores so I can put it into this normal CDF so I can find the probability. So my lower value in this interval is 1.25. My upper value is 2.5. The mean is 0 and the standard deviation is 1. That never changes. So if you put that into the calculator, you should be able to find the probability. And they're asking you to round it to the nearest 10,000th. So put that in, hit enter, and then hit resume for the answer. Okay, your answer should be 0.0994 rounded to the nearest 10,000th, which is 4 decimal places. Okay, let's look at the second part. Okay, it says that Maria took the May version. In what interval must Maria score to claim she scored as well as Joanne? If she scored as well as Joanne, she would be the same standard deviations away from the mean. So to score as well as Joanne, she needs to be, within the same z-scores. So in this one, we kind of have to work backwards. We have some information about the May exam. So we'll say that the May exam, from reading up top, it says it has a mean of 510 and a standard deviation of 20. So what we want is, if just to look at it in terms of a picture, this is my mean, 1.25 and 2.5. These are my two z-scores, and this is the area between them. I need to find, if this mean is now 510, I need to find what these two data values are, and then that will be the interval that I need. So basically, I got to work backwards. I have a z-score. I need an interval this time. So the z-score for the first one, let's find this first interval. And I guess I can put it down here. So the z-score, 1.25, is equal to an unknown data value minus a mean of 510 over a standard deviation of 20. This time we'll cross multiply. So 20 times 1.5 is 25 equals x minus 510. Add 510 on both sides. X is equal to 535. See if you can find the corresponding data value, so this is 535, here with a z-score of 2.5, and then hit resume when you're done. Okay, so your z-score is 2.5. You want to find a data value, which we'll call x2, minus the mean, which is 510, over the standard deviation of 20. Put this over 1 and cross multiply. You should get 50 equals x sub 2 minus 510. Add 510. You should get 560 equals x sub 2. So 560 is there. So in what interval must she score to claim as well as Joanne did? So here and here. So we write that as an interval between 535 and 560. And this is your final answer. Okay, I know that was a lot to take in, so see if you can try one entirely on your own, which is the question on the back. And then if you hit resume, the answers will be there. If you have any trouble with this one on the back, we'll go over it in class tomorrow.